Moving on, let's talk about straight angles. Straight angles have a measure of 180 degrees. As an example, you can see right here, it would look like this. So imagine we have a line here. That's our initial arm. We rotated around our second arm. You can imagine they were like on top of each other, and then the second one rotated, just like hands on a clock. It was 180 degrees of angle. Adjacent angles that add up to 180 are called supplementary angles. And let's make that font a little bit bigger. All right, that is plenty big. So when we have two angles that add up to 180, those are called supplementary angles. As an example here, this angle AOB and this angle COB, each of these add up to 180 degrees. So if anytime I see like a straight line and then there's some line coming in at an angle, whatever this angle is and whatever this angle is will add up to 180. So we can just write that out. 140 plus 40 equals 180. We can use this to solve missing angles. So for example, I have this very similar situation here. I have my straight line. I have some other line coming in at an angle. I know the angle here, CBK, is 24 degrees. I do not know the measure of angle ABK, or they've labeled it angle X here as well. So what do I know about 24 and X? I know they need to add up to 180. I know they are supplementary angles. So I can write that out. So X plus 24 equals 180. Subtract 24 from each side. I can't really show my work. I have very limited space to work here, so I'll just kind of talk it through and write out what I can. So therefore, X is going to be equal to 156. And don't forget your units. We're measuring angles in degrees. You do need to say that. There are other ways of measuring angles that we're going to learn about in other courses. So make sure you say that it's degrees. So therefore, X has a measure, or angle X has a measure of 156 degrees. Sometimes also when we talk about angles, we use this symbol in front of them, and that just reminds us that we're dealing with an angle and not just like a side length or something. Let's talk about right angles. Right angles have a measure of 90 degrees. We have our example here, and I mean, we're familiar with the concept of right angles. We've talked about that plenty of times before, and I even added it on the first page as well. Next, we have adjacent angles. So adjacent angles are angles that add up, adjacent angles, so angles that are next to each other that add up to 90 degrees are called complementary angles. If they add up to 180, they're called supplementary. If they add up to 90, they are called complementary. Now we see that in our examples here. Example here, we have a 90-degree angle. There's some line coming through it and meeting at that vertex. Whatever angle this is and whatever angle this is will add up to 90 degrees. So just as our quick example, 30 degrees plus, 30 degrees plus 60 degrees equals 90 degrees. And we can once again use this for determining unknown angles. I know I have a 90-degree angle here. This one's 75. What's the missing value, X? Well, X plus 75 equals 90, and we know that because they are complementary angles. We'll subtract 75 from each side, so X equals 90 minus 75. And so we find that angle X is equal to 15 degrees. Let's practice again. All right, what do we know about our angles here? I need to find the missing angle. So any angle that's not labeled, I need to figure it out. In the first case, let's deal with our complementary angles. Let's start right here. I know that angle DOB is 90 degrees. I know that angle DOC is 60 degrees. That's what this line means. That helps us know which lines are measuring the angle between. Let's find our missing angle here. So this is angle COB or angle BOC. It doesn't really matter which way you label it. For now, we're just going to call it x to make our life a little bit easier. So x plus 60 equals 90. 90 minus 60 is 30, so angle x equals 30 degrees, or if we want to use the naming convention here, angle BOC equals 30 degrees. When we label an angle, we just kind of look at the endpoints and the midpoint and we go in order. So BOC tells us that we're measuring the angle starting at B, 0 is our vertex, or O is our vertex, and C is the other end of our angle. Or COB, it would indicate the same point. All right, we now know most of our angles except for this one here. Let's call that Y. And let's solve that using supplementary angles. I know that across here is a straight angle, 180 degrees. I know if I add up all these values, I'll get 180. So let's add them up. Y plus 30 plus 60 plus 30 equals 180. We can collect like terms and tidy this up a bit. So y plus 30 plus 60 plus 30 is 120. Y is equal to 180 minus 120, which is 60. So angle Y is 60 degrees. Or we can say angle AOE is equal to 60 degrees. Now what happens if we close the end off here and start making triangles? Well, there's a few things we need to know about that as well. The sum of the interior angles in any triangle is 180 degrees. So that means if we add up this angle and this angle and this angle, we'll get 180 degrees. This might be hard to read, so I'll rewrite this. So angle X plus angle Y plus angle Z must necessarily equal 180. Let's use that to calculate the measure of the missing angle. So in this case, we know two of our angles. This one is missing. Let's just call it X. What do I know about the angles in a triangle? The interior angles. So that means the angles measured inside the triangle. I know they have to add up to 180. So 180 equals X plus 40 plus 55. 180 equals X plus 95. 180 minus 95 equals X. Angle X equals 85 degrees. We also need to talk about exterior angles. So how do I measure an exterior angle? Imagine that we extended the side of the triangle past, and then we measure. So this side is our interior angle. This side here is our exterior angle. If I wanted to find another exterior angle, like up here, I could continue this line and find that. Or I could continue this line and find that. All right, each exterior angle is equal to the sum of the opposite two interior angles. So in our example here, angle D, our exterior angle, is equal to the sum of the two opposite interior angles equals A plus B. It's written here, but I'll write it again to make sure you can see it clearly. Angle D equals angle A plus angle B. We were asked to practice by calculating the value of x. I don't love this example, but they could give you an easier example to start off, but let's take a look. I know that my exterior angle equals the sum of the two opposite interior angles. That means that 3x minus 10 equals 25 plus x plus 15. And what they want you to do here is to rearrange your equation, get all the x's on one side and solve for x. I don't know if I have room to do this, but I'll do it. I just might not show all the work. So 3x minus 10 equals 25 plus 15 is 40 plus x. I'm going to move all my x's to the left side. So I'm going to have 2x. I'm going to move all my numbers to the other side. So I'm going to have 50. So x equals 25. Next, we're asked to find the value of x and y. I know that the Well, I can solve this angle right away because these are going to be supplementary angles that add to 180. So y plus 92 equals 180. That means y equals 88 degrees. And we can even kind of write that in here. What else do we know? I know that the sum of interior angles in a triangle is 180. So I know that x plus y plus 50 must equal 180. So let's solve using that. 180 equals 50 plus 88 plus x. 180 equals 50 plus 88 is 158, or sorry, 138. 180 minus 138. I am going to grab my calculator for that one. I think it's like 42. Is 42. So x is 42 and y is 88. So these are just the type of questions we can answer using knowledge we already have about solving equations and using the new things we've learned about the properties of angles and triangles. Angles and parallel lines. When two or more parallel lines are intersecting with a transversal, that just means a line that's cutting across them, several types of related angles are formed. Let's take a look. And maybe we'll color code these. Corresponding angles are on the same side of as the transversal, and both are above or below the parallel lines. They form an F pattern. So what that means is like these values are going to be the same as each other. And these values are going to be the same as each other. And these ones. And these ones. So what they mean by F pattern is if we have the letter F, the angles that kind of line up there have the same measure. So 2 and 6 are the same, 4 and 8 are the same. See, like we're forming, I can actually highlight that as well quickly. We're kind of like forming the letter F here. So what do we know about the measures of corresponding angles? Like I just said, they are equal. And then we're asked to name the pairs of corresponding angles in the diagram. We kind of did that already, but let's still write it out. We did it with the color coding. So what we're saying is that angle 4 and angle 8 are the same. We're saying that angle 2 and 6 are the same. We're saying that angle 3 and 7 are the same. And we're saying that angle 1 and 5 are the same, which is basically what we said with our color coding already. We're just expressing it in a slightly different way. We also have alternate angles. These are pairs of angles on the opposite sides of the transversal and inside the parallel lines. Like corresponding angles, pairs of alternate angles are equal. And I know this sounds a little confusing, but if you can just remember like Z pattern, and then I'll illustrate on the above diagram in a moment. I'll give you the answers right away, and then we'll take a look. So which angles are the same? 3 and 6 are the same, and 4 and 5 are the same. So let's go up and see if we can see that Z pattern they're talking about. 3 and 6, and 4 and 5. Oops. All right, so let's look at our Z first of all. Our Z is going to be here. And the angles that are contained inside the Z right here are 3 and 6. Those are going to be the same angle. So angle 3 and angle 6 are going to be the same. We also said that 4 and 5 are the same. They're not in the Z, or they're like on the outside corner. So that's okay too. We can still use the same Z shape, and we can then say that these are the same. 4 and 5, yeah. Otherwise, we could also redraw or like a backwards Z kind of thing, but then that doesn't really work. So draw the Z pattern. The values that are on the inside, like the interior angle, are the same, and then the exterior angles are also the same as each other. The sum of the interior angles on the same side of a transversal is 180 degrees. What does that mean? It's just an example of supplementary lines again. So if I have my line here, I know this is 180 degrees, so angle 3 and angle 4 will add to 180. Same if we rotate, if this is our line, we have a 180-degree angle here. So 2 plus 4 will equal 180. And 2 plus 1 will equal 180. And 1 plus 3 will equal 180, because each pair of angles, kind of like it's on a straight line, and so they're going to add up to form that straight angle of 180. Same thing down here. Angles that add up to 180 are 5 and 6, 6 and 8, 8 and 7, and 5 and 7. Any pair that's next to each other. The measure of opposite angles is equal. So once again, what do opposite angles look like when two straight lanes intersect? That's going to be these angles. So 1 and 4 are going to be the same as each other. 2 and 3 are the same as each other. 5 and 8 are the same as each other. And 6 and 7 are the same as each other. So they are opposite each other. So two straight lines are intersecting. Find this angle. The angle opposite, right across from it, is going to have the same value. Let's check out our example here. We are asked to solve for angle A and for B. Well, it looks like I don't have enough information, but what do we know? Well, there's a few different ways to think about it. There are a few different lines here that are going to be equal to 48 degrees. So in terms of opposite angles, if this is 48, this is also 48. We can also use our Z pattern. If this is 48, this is also 48. And then how do we solve for angle B? Well, this is a straight line. These are supplementary angles that add up to 180. So A plus B equals 180. So 48 plus B equals 180. So B equals 180 minus 48. So B equals 132. Sorry, 132 degrees. Next, we are asked to solve for A and B and C and D. So once again, this takes a few pieces. You need to look at the different properties that we've learned. So let's do this one piece at a time. I would like to start here, first of all. I'm only missing one piece of information. I know the 123. I don't know the C, but I do know these are supplementary angles that form a 180-degree angle. So C is going to be 180 minus 123. So angle C has a value of 57 degrees, and I'm going to write this in. Are there any other properties I know right now that are going to help me? Well, we know that angle A is going to be 55 degrees because of the Z pattern. I have two parallel lines and a line going across them. We form our Z, 55 degrees here and 55 degrees here. So angle A is 55 degrees. Now we can solve our other interior angle. I know that all the angles in a triangle add up to 180, and I don't have a lot of room to write here. Well, I'll see what I can do. So angle D plus angle C, which we know is 57, plus angle A, which we know is 55, equals 180 degrees. So D equals 112. Oops, sorry. D plus 112 equals 180. So D is equal to 180 minus 112. So D is going to have a value of 68 degrees. Finally, let's solve for angle B. Well, we have a Z pattern again. We have our Z shape here. This is 57, so this must be 57 as well. So angle B is 57 degrees. Let's label briefly how we found these things. So we use the Z pattern here. To find angle A, we also use the Z pattern. To find angle C, we use supplementary angle, so we can call that SAT, supplementary angle theorem. And at the bottom, we used interior angles, or the triangle interior angles. Triangle interior angles. Just as a reminder of what methods we used to answer this. I know this is a lot, this can be hard, but as you do smaller questions, you'll build up the pieces. You'll get used to working with Z pattern or supplementary angles or complementary angles, or remembering that the sum of the interior angles is 180, and then becomes a puzzle where you're just putting the pieces together. So this won't be like the first question you're asked in the homework. They should start you off a little easier. Finally, for the homework, please try number 1 through 8 from Unit 6, Lesson 1. If you have specific requests, I can post a homework video. Otherwise, I'm probably going to leave it at this for now. Double check your answers in the answer key. If there's anything specific you're stuck on, or you have a specific question you want me to go over, either in writing or homework video, just send me a quick message and we can do that. Good luck.